So the leading coefficient tells me which way the polynomial ends. Where does the polynomial end? On the left or the right? On the right, right? You read left to right. Left is the start, right is the end. So if the leading coefficient is positive, how do you think that graph's going to end? It's going to end going up, right? So if the leading coefficient is positive, the polynomial ends up. If the leading coefficient is negative, the polynomial is going to end down. Does that make sense? All right, and everybody knows the leading coefficient is the highest degree, and it's the number in front of that variable. Okay, do you understand why we had to know all of that in the beginning of the unit? So the highest exponent tells me how the polynomial starts. If the exponent is even, it's going to start and end the same. If the exponent is odd, the polynomial starts and ends opposite. Now this will make more sense once we put it into practice. Okay? Does anybody remember all this from Algebra 2? Kind of, sort of. All right. So if you have an odd exponent, that's like y equals x and y equals x cubed. The leading coefficient's greater than 0. Okay, so if it's greater than 0, that means it's positive. So that means it's going to end up. Since the odd exponent, that's going to end opposite. Okay, so if it ends up, it's going to start down. So y equals x is a linear function, so it makes a straight line. So here it started down and ended up. Now the good news is you have your calculator that's going to help you verify these things. Okay, you also have Desmos. Okay, again, x to the third. In this case, in case you don't remember, it looks something like that with 3 roots. So end down, start down, end up. Does that make sense? Okay, if we have an odd exponent and the leading coefficient is negative, how is a negative coefficient going to end? Down. So in this case, we would have y equals negative x and y equals negative x cubed. Okay, so same ones, except for now, instead of my slope being positive for my linear function, it goes to the right. Now it would go to the left. So it would start up and end down. And the same thing for my cube root. Start up, end down. To kind of bringing back some memories you may not have liked. Sorry. All right. Even exponent. So in this case, it would be like y equals x squared and y equals x to the 4th. Does that make sense? We know an x squared is a quadratic. We know it makes a parabola. So if it's even exponent, it's going to end the same as it starts. And since this is positive, they're going to both go up. So that parabola is going to open up. And we know that because a is 1. Right? So these things all build together. When you have a 4th root, it normally makes like a W shape if you have real values, and they're both ending up. Is that making sense and coming together? Again, you're going to have your calculator. You'll be able to talk about that. Okay, if it's an even exponent leading coefficient's negative, we have y equals negative x squared and y equals negative x to the 4th. In this case, we know that negative does what to that parabola? It makes it reflect, right? So now it's going to end down. And that W is also going to go down. That should be a curve there. All right. So that's just kind of a general idea of how to see it. Good? All right, so let's look here. The degree determines the maximum number of turns, okay? Like this one has how many turns? This parabola here? 1. So the maximum number of terms is the degree minus 1. So you take, like this is the degree of 2. 2 minus 1 is 1. So that's one term. Here the degree is 4. 4 minus 1 is 3. So there's 1, 2, 3 terms. So that's the maximum. Now that doesn't mean they're all going to have that many, because sometimes we may have imaginary numbers, right? And things like that. That's the maximum number of terms your graph should have. Okay? So if the degree is 5, that would be 5 minus 1. So the maximum number of terms is 4. Okay? So the graph does not need to have that many terms. All right, multiplicity. Remember the other day where we got x equals 2, I think it was, twice, and you were like, do I list my 2 twice? And I said no, but next week we'll talk about how to list that. Remember that? So that's called a multiplicity. It shows me the number of times a factor or a solution appears. The number of times a factor or a solution appears. So if you have a multiplicity of 1 and we were graphing this, then say it was like this, it's going to cut through. It's just going to be like a straight cut through, like if you took scissors and cut. Okay, so it's just going to go straight through. If you have a multiplicity of 2, does anybody remember what it does for a multiplicity of 2? Okay, so it bounces. It's like a ball. It's going to bounce, and it can do it upside down or this way, so it could do reflection. So I always look at this as a bounce. So anytime a factor appears twice, it's going to make a bounce wherever it appears at that 0. Okay? If you have a multiplicity of 3, this is the one that's kind of hard sometimes to see, but it goes flat through there, and we call it a wiggle. Now, these aren't mathematical terms. These are terms to help you remember. Okay? So you're not going to find these in any math books and things like that. This is a teacher made this up, and it made sense, and we just use it sometimes. Okay. So we know that x-intercept is where the graph crosses the other x-axis. Other terms are solutions. We've said this many times. Roots and zeros. To find these, you need to set the factors equal to 0 and solve. Okay, any questions there? Everybody good? Let's go to the next page. So we've been talking about the fundamental theory of algebra and different things. According to the fundamental theory of algebra, the degree of a polynomial will represent how many roots or solutions the polynomial has. Okay, so if we consider the polynomial that has x equals 3, -1, and 2, what is the minimum degree that that polynomial will have? Consider the polynomial function that it has these zeros. So what is the minimum degree? How many zeros do I have there? 1, 2, 3. So the minimum degree is 3. Does that mean that's the highest degree? No, I could have some imaginary solutions that aren't listed, right? Okay, create the polynomial in factored form. Factored form. So I would take this, and instead of x equals 3, it would become, oh, wait a minute, we're doing g here. X minus 3. So g of x, here some of you don't put this, but when you're creating a polynomial, you need to put the function, right? So it said g of x. So g of x equals x minus 3, and x equals -1 becomes x plus 1, and then the last one would be x minus 2. So now I want you to expand that. So I'm going to, okay, so graphing polynomials in factored form. Find the zeros in their multiplicity. The multiplicity is the zero of the factor, or how many times that factor, the number of times it occurs. Okay? Everybody, we just did that, so the number of times that factor occurs. What's the matter?
Did you finish the other one?
Yeah, that was the answer. I think I'm going to put 0 in there. I like it better. Sorry. Plot the zeros on the x-axis. Determine the start and the end behavior. Use multiplicity to connect the zeros. All right. So first thing we're going to do is find the zeros. So what are the zeros of this?
4, 1,
X equals 4, 1, and negative 3. Does everybody understand that? Do any of them have a multiplicity? They're all multiplicity of 1, right? They all occur one time. Okay? What is the degree of this function? How many zeros are there? 3. So then what is the maximum number of turns? We do 3 minus 1 and get 2. All right. The polynomial start, I have to figure out what how the polynomial ends before I can figure out the start, right? Because it's either going to end the same or it's going to end the opposite, right? Start and end the same or opposite. Okay, so the way the polynomial ends, the leading coefficient here is positive. So it's going to end up. The degree is 3, so that means it's an odd degree. So odd is opposite, so it's going to start down. Does everybody understand that? So if it starts down, as that's on the left side, as x goes to negative infinity, y is going to negative infinity because it starts down. As x goes to positive infinity, y is going to positive infinity because it's ending up. Does that make sense? Yes? All right. Equals 4. That would be here at 4. X equals 1 and negative 3. Does everybody understand that part? Okay. I know it's going to start down. So I'm going to put this one going down, and I know it's going to end up. Good there? So then we're just going to go boop, boop, and go.